So this video will be from Linear Algebra, and we'll be discussing about the basic concepts of linear algebra. Firstly, there is a binary operation. So how to define binary operation? For that, let there be a set G, and there exists some element that are belonging to G. For example, I'm taking A and B. So there is an operation star. If A star B belongs to G, then the star is a binary operation. And this whole property is also called closure property. So which will be useful later in the group. Then comes algebraic structure. What is an algebraic structure? The set G with the binary operation is called algebraic structure. Then comes the third concept, which is very important, that is called group. Okay, so I'm clearing the screen, and next I'll be discussing that only. Group. So we have discussed two properties till now. So in group, if there exists a set, let's call it G, and if it is satisfying the closure property, first of all, which was like this: if A and B belonging to G, then there exists an operation called binary operation. A star B also belongs to G. So that is called closure property. Next comes associative property. Associative property. So for example, in this one, if I take three elements, A, B, and C, from G itself, the set G, then it should be like this: A star B star C must be equals to A star B star C. Means if I do the operation first in A between A and B, and then I perform the operation on C, it must be equals to the operation done on B and C first, and then we are multiplying it with A. Then comes the third property, that is named as identity. So for a set to be a group, there must exist an element. There must exist an element which will work as an identity for the group. Let's say there is an element A belonging to G, and there is an E that belongs to G. So the property says A star E must be equals to E star A, and that would be equals to A itself. If I perform this operation with E taking as the right identity, or I perform the operation with taking E as a left identity, it should give me A. Okay, the element itself. Then comes the fourth property, that is named as inverse. So this was a property named existence of identity. That means identity should exist, and this is the property named as existence of inverse. All right, so in this one, let's say A belongs to G, and there is an element named as A dash belongs to G, then the property says A star, that is binary operation A dash, is equals to A dash star A is equals to E. That means if I take A dash as a left right inverse, or I take it as a left inverse, whenever I should multiply it with A, it should give me the identity for that group. So these are the four properties. If any of the set G is complying with them, then it should be named as a group. Then G is a group. Then G is a group. So after all these properties, we have talked about the group. Then next term comes, that is called as abelian group. Now, what is an abelian group? For the name itself, it is clear that it should be a group first. So if I talk about, let's take a group G. If there is a group G, then it must satisfy a fifth property that is named as commutative property. So according to this property, if I'm taking two elements, A comma B belongs to G, then they should be like that, and star is our binary operation. A star B is equals to B star A. Means these two things should be equal always. So next thing, after this comes a term, field. Yeah. So let's discuss the basic properties of field as well. First of all, field, there is a algebraic structure that should be of this form, and it should be following these postulates, which I'll be writing here and we'll discuss. So first postulate is it should be a abelian group. Abelian group with respect to this addition. Abelian group. F plus must be a, this algebraic structure must be a abelian group. Then comes the second one. It should be a abelian group with respect to the multiplication operation as well. Okay, so this algebraic structure should be a abelian group as well. Now comes the third important property, that is multiplication is distributed with respect to addition. Now, what does that mean? A dot B plus C. That means A multiplication B plus C is equals to AB plus AC. So A is basically getting multiplied with B as well as with C. So that's all for today.